You're here because you want to master titration calculations with a University of Cambridge graduate. This is actually part 8 of our mole concept lecture series. If you haven't watched our previous lectures on mole concepts yet, please be sure to check out our playlist or check out our link in the description below so that you can further master your mole concept by watching the whole lecture series in its entirety. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. Okay, so now that we've talked a lot about our calculations, right, how can we apply this practically? Well, usually in chemistry we'll do this thing called titrations, okay, and in our titrations will involve a lot of calculations, right, and you'll most likely be practicing this in the lab, and in your worksheet there's going to be a lot of more calculations. So first, in titration, right, there's this thing called the equivalence point, okay, which is when the reactants have reacted just nicely with each other, okay, and this is usually via mole ratios, and then your end point is when the indicator change color. So usually the equivalence point and the end point coincides with each other, right? And then some of your common indicators are as such, right? You can go and memorize this if you want. The color changes are kind of important. Usually the ones that are commonly used is like methyl orange and phenolphthalein, and these usually are the color changes that you have to go and memorize for your titration, right? Another important formula that you might need to use is the dilution formula over here, right, where concentration of 1 and volume 1, when you dilute it, right, means you add more water, for example, okay, you increase the volume, and then the concentration will decrease in the process, right? So you can just plug in the values, right, and then you can easily get like one unknown that you're trying to find with this formula over here. So how can I apply my titration calculations, right? Let's take a look at this example. So aqueous sodium sulfate can be prepared by titrating dilute sulfuric acid with aqueous sodium hydroxide. The equation is as such, so this is number 1, right? We want to balance the equation. Then they say 25 cm cube of 2.0 mole per dm cube sulfuric acid was used, right? So let's consolidate the information first. This is 25 cm cube, and then they say this is 2.0 mole per dm cube. Alright, then they say calculate the volume of 0.5 mole per dm cube of sodium hydroxide used. Okay, so we know the concentration here, but we don't know the volume, which is what we're trying to find, right? And then after that, say calculate the mass in grams of sodium sulfate produced in the reaction. Okay, so after that they ask you to find the mass here. This is part B, this is part A. Okay, so let's find part A first. So for part A, right, the rough process is as follows, right? We have information on H2SO4. We want to start with finding the number of moles of H2SO4. Then we can use mole ratio to find the number of moles of sodium hydroxide. And then we can find the volume of sodium hydroxide, and then we can find the number of, after that, this is part A, so then after that you can find the number of moles of sodium sulfate after that, and then you can find the mass of sodium sulfate. So again, you can still write a rough thought process over here. So let's start off with this. Let's find the number of moles of H2SO4. This is equals to the concentration of H2SO4 times the volume of H2SO4, right? So this just equals to 2.0 times 25 divided by 1000, because it needs to be in dm cube. This will give you 0.05 moles. Okay, and let's use a mole ratio. So number of moles of NaOH is to H2SO4. As you can see above, this is actually 2:1. So the number of moles of sodium hydroxide, right, you need to times 2. So this is 0.1 moles, right? And from there, when you have the number of moles of sodium hydroxide and the concentration of sodium hydroxide, you can get the volume used. So your volume of sodium hydroxide, this is equals to the number of moles of sodium hydroxide divided by the concentration of sodium hydroxide. Okay, this equals to 0.1 divided by 0.5, which equals to 0.200 dm cube over here. If you convert to 3SF. And then after that, let's look at part B. So part B, right, you want to find the mass of sodium sulfate produced. So this is just number of moles of sodium sulfate divided by number of moles of H2SO4. Let's do a mole ratio. This is 1:1. So the number of moles of sodium sulfate, okay, equals to 0.05 moles. It should be the same as the number of moles of sulfuric acid. And then you can find the mass of sodium sulfate that's produced, which is, take this times the MR, which is 23 times 2 plus 32 plus 16 times 4. Okay, and then you can get a value of about 7.10 grams over here. So this is exactly how we want to apply our chemical calculation formulas all into one titration question. Okay, and let's take a look at the next question over here. So they say concentrated acid has a concentration of 12 mole per dm cube. So what volume of this concentrated acid is needed to make 1 dm cube of the dilute acid with 1 mole per dm cube of concentration? So here, you know that this is definitely testing you on dilution, right? And you need to use the formula, which is just C1V1 equals to C2V2. So if you plug it in, right, you had a concentration of like 12 mole per dm cube, right, times a certain volume which you're trying to find, and then you're going to get 1 mole per dm cube times 1 dm cube at the end. So if you do this, you can easily calculate the volume out already. So this volume is actually just 1 divided by 12, which gives you a value of about 0.0833 dm cube. So using this formula, you can easily just find out how much volume you needed in the first place as well. Okay, so to wrap things up, okay, this is just a summary of some of your common formulas that you use in mole concept, right? And you usually have these little triangles over here, and I like to use these, okay, because we just memorize the triangle. It's very simple after that. Okay, you can also memorize the real chemical equation if you want, or the real mathematical equation, I mean, and that works too, right? It's up to your own preference, right? Some people like this triangle, right? And how to use this is very simple. For example, for Avogadro's constant, we have this first triangle, and if you have the number of moles, for example, and you want to find the number of particles, you just take number of moles times the 6.0 times 10 to the power of 23. Now, if you're given the number of particles, for example, and you want to find the number of moles, then because it's on top, then you just take this, right, divide by this, and then you can get the number of moles over here. So hopefully these triangles really help you, okay, in terms of like memorizing some of these formulas. Okay, you can't really proceed with mole concept unless you go and memorize these formulas first. After that comes the application. So I would advise you go and practice like 1,000 mole concept questions, and you only get better from there. Okay, it's a very important concept and topic that you have to master and get full marks in the exam. Okay, because it affects a lot of your chemistry fundamentals, right? It's going to be even further tested, especially when you go to JC chemistry. Your mole concept needs to be super strong. If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.